Okay, and I'm going to go through the November 2010 paper 1 in preparation for our exam on Thursday. Within this YouTube video, you should see a link to the paper. So if you haven't got it, what's a good idea to, before you even start, is pause this video and go and print off a copy so you can work through these questions with me. The best practice when doing one of these papers is not just to copy me as I go and not really listen to what I'm saying, but to pause the video, attempt the question, watch what I'm doing, and then mark your own work. Okay, so first question is a question on scatter graphs. We've done a lot of work on scatter graphs recently, so if you look at this sort of question thinking, right, we can clean up here. So we're told that we have a number of visitors to a historical site. I'll tell you what, the amount of times that I go through this paper, don't even read this, it may be important, so make sure you read the question. I've looked at that, it's just scatter graphs, so let's just make sure we know what we're doing. Total donation were given, recorded for 6 weeks. The table shows the results below. Okay, so there's those results, and then on the graph paper provided, draw a scatter graph. Okay, so let's just check what the scale is before we go on too far. So I've gone from 0 to 50, that's a jump of 50. So 50 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 little squares. 50 divided by 10 tells you one little square going across is worth 5. And then going up, I've gone from 0 to 200, so that is a jump of 200. 200 divided by 10 little squares going up tells you one little square is worth 20. Okay, the next thing we'll do is get a pencil to plot the points. Don't want to do this in pens if you mess it up, especially on the real day. Then that's it. That's your whole 2 marks gone at least, and maybe all of the ones underneath. So 90 for number of visitors. So number of visitors there. 90. So there's 100. I'm going to count down 2 from 100. So 95, 90. So I worked out each square is worth 5. Then up to 360. So where there's 200, there's 400. So 300 must be there. And then I'm going up in 20s. So 320, 340, 360 by there. Okay, I tend to do little crosses. Some people like to do little dots. Whatever is easiest for you. Stick with the way you've been taught and the way that you're happy with. 140 and 650. There's 100. There's 150. Come back to would be 140. So 145, 140, and then 650. So that's going to be 620, 640, 660. So that'll be in the middle of these two here. So it should be hovering in the middle. And then I've got 10 and 40. So 10 and 40, so across to 5, 10, and 40, 20, 40, really close to the origin there. And then got 60 and 150. There's 200, 180, 160, 140, so it must be in the middle there. Then 100 and 410. And then 180 and 700. So there's 150, there's 200, 175 in the middle, up to 600, and 700 must be in the middle of those two, and then, because it's 180, that's 175, 180 by there. Okay, so there's my 2 marks achieved for that. Describe the correlation. We want one word here and one word only. It should be positive. By eye, draw a line of best fit. Now, when it says by eye, draw a line of best fit, that does not mean do it without a ruler. You still do it with a ruler. It just means you don't need to plot the mean point. Okay, if it said draw the line of best fit, it is worth 2 marks. What you'd have to do, and this would be a calculated question then, a non-calculated question, you're supposed to add up all of these points here, divide by 6 because there's 6 of them. Same with this one here, add them all together, divide by 6 because there's 6 of them. Plot that point here, draw a circle around, and your line of best fit would have to go through that. But we very, very, very rarely saw that come up when we look at our past paper questions. So, draw my line of best fit. I want to roughly have the same amount of points each side of the line. So 1, 2, 3. I want to have 3 above the line where I've got it, so that looks about 3. It's a common misconception that it must go through the origin. It doesn't need to. It needs to best follow the data. For me, I think that's going to look pretty good. So I'm going to draw that now. Yeah, I'm happy with that looking after that. So I've got 1, 2, 3 there, and then I've got 1 on the line, 2, 1. You could maybe argue actually that mine should be a little bit lower down. It should be maybe here instead. So I'll do that a bit bolder like that. And then obviously if I had a rubber, if I thought ahead and got a rubber, then it would have looked a bit better. Okay, but in the exam you'll have one of those it's important that you make sure that your line does have roughly the same amount of points each side. So 1, 2, now my line, 1, 2 that side, and then 2 on the line. Yes, lovely, much better. Okay, use your line of best fit to estimate the number of visitors to the historical sites on a weekend when the total donation was £500. £500, there's 400, there's 600, here's 500. I draw a line across until I hit my real line, so that's the second one for me. There, and then come down and read off what the donation was. Okay, so I can see that my answer is 1 past the middle, so that would make it 130 for me. It does not matter if you have a different answer there. I would have thought your answer would be around about 130. If it's not, if it's like say 200 or if it's like 50, you've drawn your line bad and you'll lose that mark, but you'd still get that mark as long as you actually read it off your exam solution properly. So far we've got 2, 3, 4, 5 marks in total. Over the page, and we're seeing some questions on transformation. Still some mistakes creeping in here. Okay, good idea to pause the video and have a go at these questions. I'll probably remind you that numerous times also because I'm having my breakfast. I'm on my breakfast with tea. I may stop as well myself. Now, the main mistakes that are done here, most of you are getting, yeah, scale factor 2 means twice as big. That's very important, but you're not doing it from the center properly. So when you're looking at the center of enlargement, we're saying, how do we get from the center to this point here and go either across or down? Don't talk about diagonals. We go across 1, 2, and go down 1. Reset. Put your pencil back there. Make that twice as big. So 1, 2, 3, 4 across and down 2. That's where your first point is going to be. Now, I quite like drawing by the side, across 2, down 1, like that. So in my enlargement, I know I've got to go across 4, down 2. Okay? Now, in terms of what I'm going to do next, you could carry on doing that for every single corner. So I could say, right, how do I get to this one? I go down 1, 2, 3, 4, 5, and across 2. So now I need to do twice as much, go down 10 and across 4. Okay, but what I prefer to do is count how long this line is. It's 1, 2, 3, 4 long. So it now needs to be twice as big from this point. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I've gone past that. 8 there. I think the previous answer. Let's just check that again. 1, 2, 3, 4, 5, 6, 7, 8. The next one I'm going to do is this line here, which is 1, 2, 3 in the original. So 1, 2, 3. 4, 5, 6 because it's twice as big. Now, you want to steer clear of any diagonal lines. Don't do the diagonals too hard to spot because it's not a true diagonal. It doesn't go through the corners. If it did, it'd be easy enough, but it doesn't. So I'm coming to this top line here. Straight lines are easy to do here. If they're not, it's a better idea to actually do what I talked about by here, going across and down, okay, and then doubling that. But I can do with this one. 1, 2, 3, 4, 5. So that's just going to be twice as big. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by there. Okay? All I do now is a dot-to-dot drawing. Make sure you use a ruler. Make sure you use a pencil. Make sure you've actually counted it properly. There's 3 easy marks. You don't want to be losing these. They're too easy to get. Very easy way I check. You see this one here. I've gone across 1 and up 2, and it's gone through the corner. Across 1 up 2, across 1 up 2, across 1 up 2, across 1 up 2. I did that 4 times, whereas in the original I did that twice. Don't know whether you like that method, but I always do that to check myself. So another 3 marks there. And this question's a bit mean, this one. It says, fully describe the transformation that transforms triangle A into triangle B. Now there's 2 things that you could have, but there's one for me that's more obvious than the others. To me, it looks like that triangle is looking back into itself. So we call that a reflection. So a reflection, and where has it been reflected? Because that will get me one of the 2 marks. You see here it's 2 marks. That's only one thing. So where is it reflected? Well, where would I put the mirror line for that? So I'm just going to find the middle of it. So come there, from there, or there. I'm going to draw a line down here. And you should know, especially if I work this week, what that line is. Okay, so really try and think of it before I tell you. I'm looking at that. I'm looking at the value it's going through there, 1, and I'm looking at the axis it's going through, x. So I'd say reflection in line x equals 1. So 1 mark for the reflection bit, 1 mark for the x is 1. Okay, so now we're on to another 5 marks there. So with the 5 that we had before, we're on to 10 altogether. So I might write this as what we call a cumulative total, which is the running total. Okay. Okay, the next question here, we don't particularly like that question because there's so much graph paper going on here. We prefer like a scale like that. That's nicer, but we'll have to deal with what we've got. It says rotate the triangle A through 90 degrees anti-clockwise. So think of the way that the hands turn around the clock. That's clockwise. So anti-clockwise would be the opposite way to that. So just be careful. Very easy to lose this mark here by doing the wrong thing. About the origin. What's the origin? It's important we know that. It's where the axes meet. It's the point 0, 0. Okay, so tracing paper, I went through my covers and found some baking paper. Don't know if that's any use to you when you're doing this at home. So what we do is we trace the shape and we trace the center of rotation. So rotate through at the origin. So here, now what I've been telling you to do is draw the crosshair. That's sort of already drawn there for me because it's the axes. So I'm going to draw crosshair there, and then I'm going to draw shape by here, but make sure that the tracing paper, yeah, I can see mine slipped. Make sure the tracing paper doesn't slip off your origin that you just marked. There, there, and there. Okay, so there's my origin, there's my shape. What I'm going to do now, let's not come out the clearest. Now, holding my pen on the center, anti-clockwise, so not this way, that's the way that the clocks go around, anti-clockwise, 90 degrees. So the crosshair will tell me when it's been split into 90 degrees, because it should look like it matches up on itself. There we go. So there's my crosshair, there's my shape. So what I'm going to do now is press down really hard. So I'm hoping to have left an indent on my paper, which yes, I can see. Now I'm going to use the pencil to draw this bit. There, there, and join them up there. Okay, so there's my my shape there. Okay, part D, 2 marks there. Enlarge the shape PQRS using center 0, 0. That's the same thing as the origin. They could have said origin here again by the scale factor of half. Okay, so that means we're making it half as big. If we're making it half as big, then really we're divided by 2. So how do I go from here to this corner here? I go across 6, up 6, back. Go back to where you started, and halve it. So instead of going across 6, we're going to go across 3. 1, 2, 3. Instead of going across or up 6, sorry, we're going to go up 3. Okay, so you halve it. How long is this line? 1, 2, 3, 4. Halve it. 1, 2. How big is this line going up? 1, 2, 3, 4. Halve it. 1, 2. And then because it's square, I can just fill in that last one there. So there's my marks there. You know, when we look at marks for saying tough, you know, we're expecting you to lap these up. These are very, very important marks, these ones. Okay, 2 marks there. So now we're on 14 altogether. Okay, and parallel lines, have a quick think of what to do. Okay, so best way to do these, along this line only, I'm going to write down any acute angle is 55. So that includes A. And it includes B as well. There we go, easy marks there. But that's only along this line. This line here, nothing to do with this line at all. Okay, so we can't put 55 in everywhere. So A and B were both 55. Right then, along this line here, any acute angle is 38. Now you can see here, this angle up above it by here is quite clearly not acute. So that's not 38 here. But this is 38. This is 38. This is 38, so that's angle D sorted, and that thing there would have been 38 as well if we had that line a bit longer. So D was 38. Now angle C there, to work that out, I can see that I've got angles on a straight line, and I know angles on a straight line add up to 180. So I want to do 180, take away 38. 0 take away 8 we can't do, so I've already borrowed 1 from the 8. So 10 take away 8 I can do, that is 2. And then 7 take away 3 is 4, and then 1 take away nothing is 1. So C equals 142. It's a very easy way to check that. 142 there, if that was, add 38 should come to 180. So if I add on the 8, I get 150. 150 add 30 is 180. Yes, so I've got 4 marks there. So that puts me up onto 18 marks. Okay, without reading this question, I'm assuming it's going to be bearings or something to do with that. Scale, obviously, quite big letters there, so that's obviously important. It says, write down the bearing of X from Y, from the point Y. So that's really important. That's telling you where to go and put your protractor. So of X from Y. The first thing we do is join up the 2 dots. Join them up. Then, get your protractor. I've got a 360 which makes my life a lot easier. I'd recommend you buy one before Thursday. Otherwise, you need to know how to use a 180. I haven't actually got a 180 one at home, okay, but I'll try and show you the best as I can what to do. So 0 here must be on north. Your bearing must be in 3 digits. You must count clockwise. So clockwise coming around here, you can see there is obviously being done on purpose. It's 260. I can see quite clearly it's 260. That's in 3 figures. I've measured from north, and it's in 3 digits. If you had your 180, you should have put, so like half of your protractor facing that way. Now that obviously doesn't go through the line, so we account for that by then rotating your protractor around. So now it would look like this, and then you count how many degrees it is on from 0 down here, which is 80. And then 180, add the 80 that I've just found, comes to 260. But it makes your life so much easier if you have one of these 360 ones. So I really can't stress the importance enough of going out to WJEC Smith, Sainsbury's, Tesco's, buying a 360 degrees protractor, even if it's just for this one exam. You know, sell it afterwards on eBay, make a fortune. A point Z is to be plotted on the above plan. Find the bearing of Z from X is 100 degrees, and the bearing of Z from Y is 225. How far is Z? So I need to go and find and mark the position of Z on the above plan. So I'll go and do what it says first. It says Z was 100 from X. So I get my protractor, plop it on X there, make sure it crosses over properly on there, and make sure the north line fully on there, okay? And then I'm coming across 100 there. Mark it coming out of the protractor properly, not like this. I've seen some people doing that. That's about like 4 degrees difference there. There's the 100 coming back from the 100 like that. Really, I should have done that in pencil as well. Go through that point, come to the edge of the paper. If you go to the edge, you definitely won't have to do anything else. If you don't, you may have to do some more. So then on Y, and this is why we like the 360 degrees protractor, makes my life easier. I'm looking for 225, so I can come around here to 225, mark it, and again, mark it properly coming out of there, and then drawing it across, done. Okay? That's Z, where they cross, okay, what we call the intersection. It says, how far is Z from X in meters? So I know this scale from before, I pointed that out right at the start. 1 centimetre is represented by 20 centimetres. So if I go and measure that, I can see it's 5 centimetres. So it's not a bad idea to actually write by it 5 centimetres. That's what it really is. But when it asks me in meters, then obviously I need to use that scale. So I'm going to say 1 centimetre equals 20 meters. Now, there's 2 ways we could do this. We could use our knowledge from exchange rates and do something like this. Let's say to go from centimeters to meters, I'm timesing by 20. So 5 times 20 is 100 meters. I love that way. I also like this way where you say 1 centimeter equals 20 meters. And then all you do is, because you have 5 centimeters up here, is that you just write the centimeters under the centimeters. You say, well, what have you done to 1 to get to 5? Well, I've times it by 5. Whatever I do to one side, I must do to the other. So 20 times 5 is 100. They both give the same answer. They're both correct. It's whichever one you prefer. Okay, we've got 5 marks then. So we're on to 18 before. We're now on to 23 marks for the entire paper so far. Okay, these ones here, now we like nth term, not as big a fan when it comes into the patterns, but we can still do lots and lots and lots of maths here. So we'll try and work out something in a second. Okay, now I'm noticing here pattern number 1 has 1 black square, pattern number 2, 2 black squares, pattern number 3, 3 black squares, pattern number 15 has got to have the same number of squares, surely, 15. And then, let's make that a little more like a 5, and then 100 would be 100. Now this is a bit where people get confused, like n, what's that mean? Well, what do you notice about the pattern number and the number of black tiles? They're the same. So if that's n, this is also n, okay? Now here, number of white squares. Now, I don't like it being written like that. I'm going to write it down in this working out bit here. So 4, 6, 8, okay? Now, you know what to do here. What we do is we look to see the difference between them. So we're going up in 2s. If we're going up in 2s, that means it's going to be 2n, okay? But you need to go and find the term in front of it. So plus 2 each way. So to come back, I must take away 2. So then 4 take away 2 is 2. What sort of 2? Plus 2. So I'm doing my nth term straight away because it's only going to help me work out the 100th pattern and the 15th pattern. So 2n plus 2 goes in there. So for the 15th term, I would do 2 brackets plus 2, and I'd sub in 15 to find the 15th term. And that would be 30 plus 2, which is 32. I would do exactly the same for the 100th term. I do 2 brackets. This is what we've done. We've done lots of this. We've got to make sure we're getting these marks. It's very important. Something in 100 to find the 100th term. 2 times 100 is 200 plus 2 is 202. Massive 5 marks there. What are we on before? 23, 28 now. Pretty much there towards your C if you've got all of these questions. You need 30 to get our C to be safe. Okay, the first one of these quite easy. Second one a little bit more difficult. Third one, if you spot it, you spot it. If you don't, you don't. Okay, so this question here, 234 equals times 789 equals 184,626. Well, I know this answer must be based on 184,626, but you notice I've written them out all spaced out, and that's because there's a decimal going in somewhere. Maybe before there, maybe it's got a couple of zeros left on the end. Don't know, it could be any of those. So, how many decimal places has this one got? 1 decimal place. How many decimal places has this one got? 2 decimal places. That is a total of 3 decimal places. So my answer's got to have 3 decimal places. So 1, 2, 3, decimal point goes there. There's a very easy way to check it. I'm going to estimate it. If I was to estimate it, it would be what, 20 times 8, roughly? What's 20 times 8? 160? Yeah, that's pretty close to 160. I feel pretty confident that's right. This one here, I'm going to use this fact, but before I do it, I'm going to make that to 2.34, okay? Now, if that was 2.34, so I want to be divided by 2.34 in a minute, times by 789, that would equal, now that's got 2 decimal places, so my answer's got to have 2 decimal places, so it would be 1846.26, okay? So then if I was to rearrange it, I could say that 1846.26 divided by 2.34 should be equal to 789. And another way of writing that is 1846.26 divided by 2.34 is equal to 789. Okay, so that's using the fact I've rearranged it so I'm dividing by 2.34 instead. And I can see there, that question there, that answer's 10 times bigger up on the top there. So that means my answer here has got to be 10 times bigger. So the answer to this thing here would be 789 and then add a 0 on the end to make it times 10. And because I've got so much work in there, I'm going to really make my answer stand out and say answer. Okay, make it clear to someone who's marking your work what your answer is. Okay, and then finally this one here, the times 789 bit's obviously easy. I'm just a bit taken aback by the 117. I'm thinking, well, how can I do that? And I don't want to be doing it. If I'm given that, then I must use that. If they see me doing any work anywhere else, I can't get the mark. So 117, what's the link between 234 and 117? Got it. It's half. 234 divided by 2 is 117. So I need to halve this answer here. Okay, so I'm going to just do bus stop for that, just to make it a little bit easier. So how many 2's going to 1? Answer is 0. 2's into 18, 9. 2's into 2, 2. 2's into 6, 3. 2's into 2, 1. 2's into 6, 3. Okay, so my answer is 9, 2, 3, 1, 3. Ratio, we haven't done ratio in class for a while actually. It's definitely something we need to look at before the start of next week. Ratio 2 to 9. What you do, step 1, you will always follow this procedure. Step 1, you will add the numbers in the ratio, which will give you, there's 11 parts altogether. So 2 parts and 9 parts, 11 parts in total then. Step 2, you will always divide the number given in the question, this 385, you will divide by the 11 parts. And this will find the answer for 1 part. But I've got an issue. I don't know how on earth many 11s go into 385. So I'm going to use the same ideas I just used. I'm going to do the bus stop. So 11, 3, 8, 5. How many 11s go into 3? None. How many 11s go into 38? 11, 22, 33, 44. 44 is too big. It must be 33. 33 with 5 remainder. How many 11s go into 55? 5. So the answer is £35 for 1 part. Okay, and this ratio was 2 parts to 9 parts. So I need to double that to get 2 parts. I need to times by 9 to get 9 parts. So step 3, we times the numbers. So 2 times by 35. Say dot dot 9 times by 35. Double of 35 is 70. That's maybe easy enough to work out. 9 times 35, no idea. What's 10 times 35? 350. Take away 35 to come down to 9 times. So 0 take away 5 can't do. Borrow. 10 take away 5 is 5. 4 take away 3 is 1. And then 3 take away nothing is 3. So the answer would be 315. And then if you add those two together, 70 add 315 comes to 385, which is the number in the question. Okay? And estimate. Estimate the value of 607.45 divided by 0.2489. So a little bit of divided by decimals here. We've got to be careful with our answer. First one, easy enough. Hoping we'll have 600. The second one, 0.24. The reason why it was 600 really was because I rounded after the first significant figure. So I put the line down after the 6. So that 0 kept that as a 6, and we changed those to 0. So 600.00 if you want to think of it, it'll make my answer more difficult to get my head around. Now, you've got to put the line down after the first number here. So we're going to divide it by 0.2, okay? Not 0.25, that'll make things too hard. You can do if you want, but honestly, it's easier to do this way. Don't like dividing by decimal. So I'm going to times that by 10, but whatever I do to the bottom of a fraction, must do to the top. So I get 6,000 divided by 2. What is half of 6,000? Answer is, oh, my answer looked better. 3,000. Like I said, make sure that your answer really does stand out. And it looks good. Okay. Right, 3, 5, 7. We were already on 28. We are now on 35. We are past the C by about 5 marks. But this is about really making your C solid now. And you know, some of you, no reason why you can't get B's. Absolutely not. Question 6. It says, no calculation that the triangle. 2 things you should be thinking of a right angle triangle. You should be thinking Pythag or trig. Okay? Trig, we've got to have an angle given other than the right angle. No angles given here at all. Pythag, we've got to have at least 2 sides given to find it other than the right angle. Now they've got all 3 sides here, and they're asking me to prove that this is a right angle triangle. So to do that, I can use Pythagoras' theorem and see if these numbers, this squared, the small one squared, big one squared. So I'm going to say 6 squared plus 8 squared equals 10 squared. And that comes from a squared plus b squared equals c squared. If that's true, then it is a right angle triangle. So that would be 36 plus 64 equals 100. What is 36 plus 64? 100. Yes, it is. 100 equals 100. So I'm going to tick that and say, therefore, it is a right angle triangle. . . Okay. Now, from here, what I was going to make a point that I forgot what I was going to say. A squared plus b squared equals c squared. That's Pythagoras. So basically, if it wasn't, if I tried, like, say it was like 3 squared plus 7 squared equals like 20 squared or something like that. If it didn't equal 100, then it wouldn't have been a right angle triangle. Okay. Part B. Calculate the area of the semicircle with radius 20 using pi equals 3.14. Now this could come up. Okay, it really could come up. So we're going to have to try and think of a smart way of doing it. Area of a semicircle. So area of a circle, we should know that formula is pi r squared. Sounds like area to me. But that's of a circle. So of a semicircle, I want to chop that in half. Okay, now you'll get a mark if you can write that formula and substitute the information in. So pi is equal to 3.14. So I'm going to say 3.14 times by the radius is 20. So times by 20 squared, which means 20 times by itself. Divide that by 2. We're going to do this in number of steps now to get the second mark. Okay, we've got 1 mark there. But if you want to get the full 2 marks, you need to do this. 3.14, 20 times 20, I'm just going to write by here. What's 20 times 20? Well, what's 2 times 2? It's 4. 2 zeros, so it must be 400. So I'm going to times that by 400 and then divide by 2. Now, I know timesing by 100 is very nice to get rid of decimals. So I'm going to change that 400 into times by 100 and then times by 4, because I know that 100 times 4 is 400. All divided by 2. 314 is the answer when I do 3.14 times by 100. And then I'm going to times it by 4, then divide that by 2. To times something by 4, I'm going to double it. So I'm going to say double of 314 is 628, and then double of 628 would be 1, 2, and then 56. Okay, I've gone quick there, but you know, you can take your time working that out. So then it's 1, 2, 5, 6. But then I'm going to halve that, so it's going to take me finally to 628 centimeters squared. Okay, that's my final answer. You've got your 1 mark there. Obviously, this was loads more work, but if you sat at the end of the exam and you're thinking, oh, I've got nothing to do, maybe go and take that 1 step further and get the second mark there. So now we've got another 4 marks on that page. That takes it to a total of 39 marks. Okay, question 7, have a quick read. Okay, this is simultaneous equations. So to work it out, I need to come up with some equations here, which is going to be 3 bananas, so 3b plus 1 apple equals, now they've done that as 65p and that's pounds, so I'm going to get everything as pounds, so I'm going to say equals 0.65, okay? Equation 2, I'm going to get 7 bananas plus 2 apples comes to 149. Now they're both in the same sort of units, rather than saying 65p and £1.49, it's a little bit easier. Okay, are the b's the same, are the a's the same? No. So we've got to make them the same. Are the signs the same? Yes. That means we're going to subtract these equations. So to get these the same, I'm going to times this by 2 and this by 1. So you get 2 new equations. So I'm going to get 6b plus 2a comes to double of 65p, which is £1.30. And then this one times by 1 actually stays exactly the same. Some people say you don't need to write it out. And if you don't want to, that's fine. You don't have to. Okay, and which one of these 2 new equations has the larger b? 4. So we're going to do 4b, so we're going to do 4. Sorry, not 4b, just 4, take away 3. So that is going to be 7b, take away 6. 7 take away 6 is 1b, 1 banana. 2 apples, take away 2 apples is gone. And then 149 take away 130 would equal 19p. Okay, so 1 banana is equal to 19p. We're going to sub b equals 19p. I'm going to do it into 1 because they're smaller numbers. So I'm going to get 3 lots of 19p. Add 1 apple comes to 65p. Okay, 3 lots of 19. I'm going to write by the side 19, 19, 19. That's 3 lots of 19. 9 add 9 add 9, 27. 1, 2, 3. Add the 2. 5. Comes to 57p, right, that's 0.57, plus the apple comes to 65, take the 57p off each side, and this isn't true in real life, an apple costs a lot more than that, an apple costs, I'd say 0.08. Oh, not 0. If I said that, what I just wrote, that would be wrong. Okay, it's very, very important. Let me make this clear. 0.08 pence, wrong. A equals 0.08 pounds, right. Okay, so let me cross that one out. I could have said A equals 8p. That would be fine as well. That or that, but not the one that I've crossed out. Okay, another 4 marks there. Okay, part B. Part B, we're now starting to get into the B grade material that's tricky. Simultaneous equations is grade B. This is also grade B. Okay, we draw an upside down ironing board to help us answer questions like this. Okay, now to do that, that means that 3 has to times by the top there. So we do 3 lots of 2x plus 3 plus 6, and 6 has to times that bracket by there. So we get 6x minus 1, and then we put that all over those 2 times together, 6 times 3. And that is equal to 7 over 12. Okay, now you'll get 1 mark for doing that bit. Don't know why I did that bit in pencil, but I did. You'll get 1 mark for doing that, and you'll get 1 mark for expanding here and trying to solve. Okay, so 2 out of 4 here is very easy. The rest of them are quite hard, and I'll show you how to do the rest, but 2 out of 4 here, minimum requirement. So 3 times is by both of those, 6 times by both of those. So we're going to get 6x plus 9 plus 6x minus 6. Be careful if you get a minus there. It does funny things. It does, well, not funny things. It does the opposite things to numbers in the bracket. Just watch out for that. You may get that. Over 18 is equal to 7 over 12. Okay. Next thing I'm going to do, I'm going to simplify the top. I'm going to get 12x plus 3 over 18 is equal to 7 over 12. Okay, now that's 2 marks very, very safely there. Now, to solve this, I want to get rid of the 18. So I'm going to times by the 18 to each side. So times by 18 there, times by 18 there. So I'm going to get 12x plus 3. Now I'm going to do this in quite a clever way, at least I think it's clever. I'm going to times, whenever I times a fraction, so if I have 7 over 12 times by 18, it's the same as saying 7 times by 18 over 12. So I'm going to say that, 7 times by 18 over 12. Now I know a number goes into 12 and 18 to make my life easier, and that number is 6. So I'm going to divide the 12 and the 18 by 6, which is going to come to 3 and 2. So I get the answer now, and I'm going to have to work over in this bit here. 12x plus 3 is equal to 7 times 3, which is 21, divided by 2. Okay, and then I know what 21 divided by 2 is. It is 10.5. I'm then going to take away 3 from each side to get 12x is equal to 7.5. And then I'm going to divide both sides by 12. I'm going to leave my final answer as this in a second. X equals 7.5 over 12. There should actually be nothing wrong with leaving your answer as that. It's a weird answer though. I'm just going to double check I've done all my steps correctly in a second. Just because it is so weird, you assume you may have done something wrong. Now, first of all, have I written out the question correctly? Yes. Times those? Yes. Expanded that. 6x plus 9? Yep. 6x minus 6? Yep. 6 times 3 is indeed 18. 18 there, times by both sides? Yes. Divide by 6 is 3. Divide by 6 is 2? Yes. Yeah, I'm confident looking at that. That is my answer. But what some people may say, oh, you shouldn't do that, you shouldn't leave your answer like that, is a decimal and a fraction. So what I could do is I could say x is equal to 15 over 24. Okay, the way I did that was I doubled the top and the bottom. Okay, but you can see there how easy, in comparison, the first 2 marks are. The second 2 marks are a nightmare. It's all about getting some marks. You don't have to get all 4 marks. If you can get 2 of those marks there, we'll be absolutely chuffed to bits. Okay, so we've got another 4 marks there. With 39, so now we're up to 47 marks. And still the marks are coming. We can do all of this stuff. Okay, simplify. A to the 6 times a to the 8. That means we add the powers. So we're going to get a to the 14 up on the top, divided by a to the 7. That's it's not my 1 mark yet. I've got to get the other. That's a bit sneaky. They normally give 2 for this. And then you subtract the powers when you divide it. So we're going to get a to the 7, not a to the 2. Okay, a to the 7 is my final answer there. Expand this bit here would be x times x, which is x squared, plus 2 times x, which is 2x. And again, that's normally 2 marks as well. Make w the subject of the formula. That means we need to get w on its own. So the first thing we're going to do is expand the bracket. So we get 6w plus 6y is equal to 10y minus 7. We're then going to start getting w on its own by taking away 6y off each side. And that gives 6w is equal to 4y and then minus 7. I'm then going to divide both sides by 6. So divide by 6, divide by 6. So w is equal to 6y minus 7. I'm going to say over 6. Okay, so there's my 3 marks there. Okay, then for this question here, factorising means when you've got x squared, x and a number, it means you're going to put into double brackets. So we think of a number that times is 2 minus 12, and they add to plus x, so plus 1. So we look at just what we call the numbers there, the coefficients is the proper term. What numbers times to 12? Well, 12, 1, 6, 2, 4, 3. Okay, but to make minus 12, one of them has to be negative. So if that's negative 12 plus 1, or the other way around, we're going to get 11, or minus 11. If that's plus and that's minus, we're going to get a plus 4 or a minus 4. And if one of these is plus, one of them is minus, we're going to get a plus 1 or a minus 1. That's the combination we want. And to get a plus 1, we need that to be plus and that to be minus. Because plus 4 times minus 3 is minus 12. Plus 4 minus 3 is plus 1. So in here goes x plus 4. In here goes x minus 3. Either way around is fine. And then to solve it equal to 0, one of these brackets has to be 0. So either x plus 4 equals 0, or x minus 3 equals 0. So x would equal minus 4. X would equal 3. If you get that second bit there, brilliant. If you don't, again, it's all about getting some of the marks. It's very easy to get 2 marks there. You get 2 marks for factorising to that form. And then finally, solving the inequality here is just like equations, but instead of putting equals, we just put this inequality sign. Okay? Now, I know I need to get the smallest n, which is n. I need to get rid of it. So I take away n from that side, I take away n from this side. 3n take away n is 2n. I've still got a plus 5, and I've still got a 9 here. I now get rid of the plus 5 by taking away 5 from each side. I'm getting 2n is greater than 4. And then finally, I'm going to halve both sides, so divide both sides by 2. And n is greater than 2, and that's done. Okay? How many marks do we get on that page? 1, 2, 5, 8, 10. So we're on 47, we're now on 57 marks. And there's still more marks we can do. We can get all of these, okay? 756, expressed as a product of prime numbers in index form. Prime numbers, what are they? They're numbers that only have 2 factors, 1 and itself. We told you to write these down when you're doing these questions to help you answer them, okay? So if you know up to 29, that's brilliant because it's the first 10, but really I would have thought the first 5 should keep you safe, okay? 756. 2 numbers that times together, absolutely no idea, but it ends in an even number. That means 2 must go into it. I'm circling 2 because 2 is in my prime number list. And then I'm going to do bus stop by here and work out exactly how many 2's go into 756. 2's in 7, 3, remainder 1. 2's into 15 is 7, remainder 1. 2's into 16 is 8, so it's 378. I could have, if I wanted to, I'll do this at the bottom, split it into 750 and 6 and halve them individually. So I get 350, 25 and 3. Put them back together, I get 378, whichever way you prefer. I know this is still even, so 2 must go into it, and again 2 is prime, so I'm going to circle it, and then I'm going to do the bus stop again, but feel free to split them like I did below. 1 remainder 1, and then 8 remainder 1, 9, so 1, 8, 9. Now, 2 doesn't go into it anymore, which is a bit of an annoying thing for me because I'd like it to, because it's still quite a big number. And the tricks that we've taught you, to see if a number is divisible by 3, we add together its digits. So 189, we add together 1, add 8, add 9. 1 add 8 is 9, 9 add 9 is 18. Is 18, is that number in the 3 times table? If the answer is yes, then it is also in the 3 times table. So if its digits add up to a number in the 3 times table, it is in the 3 times table. 18 is in the 3 times table, so is 189. So I'm going to divide that by 3. 189. How many 3s go to 1? 0 into 18, 6 into 9, 3. So that is 3 times by 63. Now for me, I know that 7 times 9 makes 63. 7's in my list, so I'll circle it. 9 is not, however, so there must be numbers that make 9, and that is 3 times 3. Final bit we need to do. Now we've drilled you to make sure that you always write this out as a long list, because it's very, very useful if we ever get asked to work out the highest common factor or the lowest common multiple. So we're going to say it's 2 times 2 times 2, oh sorry, 2 times 2, times 3 times 3 times 3, so 3 of those, 1, 2, 3, and then times by 7. So that comes to, what's that come to? 2 times 2, so that's 2 squared, times by 3 cubed, times by 7. Okay, so we could get asked, is that a perfect square? And the answer would be no, because the indices aren't even. That's not an even number, nor is that. I could get asked what is the smallest number I can times by to make it a perfect square, and that's any of the numbers that have odd indices that we have to times by. So times by 3 and times by 7, because 7's indices are odd, it's 1. So times by 3 and times by 7, 3 times 7 is 21. Okay? Standard form we've not done a lot of in class. That's a number which says a times 10 to the n. But we can still get a mark, pretty easy mark, from doing 2 to the power of 8 times by 5 squared divided by 2 to the power of 2. What is 2 to the power of 8? Well, it means that we say 2 and we just keep on times by 2. So we get 2, 4, 8, 16, 32, 64, 128. Now that's 1, 2, 3, 4, 5, 6, 7. So I need to go one more. So double of that would be 256. So it would be 256 times by 5 squared is 25, and then 2 squared is divided by 4. From here, 256 times by 25, I'm going to set up in the Chinese multiplication method. Set up like this. Now you should be taking awful care there. That's not the best drawing I've ever done. You shouldn't have any overlaps there, because it can make this very hard. 256 here, 25 there. 6 times 2 is 12. 6 times 5 is 30. 2 times 2 is 2 times 5 is 10. 2 times 2 is 4. And then 5 times 5 is 25. And then 2 times 5 is 10. So you just add in the diagonals, and that is 0. 2 add 3 add 5 is 10, so I carry 1. And then 1 add 2 add 1 is 4. And then 6. So the answer is 6,400. So that is 6,400 divided by 4. So half of that would be 3,200. In fact, actually, I can use these numbers here, kind of. Half of that then would be 1,600. Okay, 1,600. Halve it, then halve it again. That's what I'm doing here. But that's not in standard form. To write it in standard form, I'd write 1.6 times 10. Now, that decimal point there has gone in between there. So how many numbers are after the decimal point? Well, 6 and then 2 zeros. So that gives a total of 3 numbers. So my answer should be 1.6 times 10 to the 3. That's another 6 marks on that page there. Admittedly, that bit was hard, but this bit wasn't. You can definitely do that. You know how to times. You don't have to do it this method, whichever way works for you. As long as you're getting the 6,000 over 4, 6,400 over 4, and then halve it to that, that's 2 marks. That's only 1. Okay, 3 marks there. 57, now we're on to 63 marks. Okay, so lots and lots of marks on this paper that we can get. Over the page, first one I'm going to skip, relative frequency. It's not the most easy thing in the world. If you want to know the answer, by all means come and see us on Monday, Tuesday or Wednesday and ask us about it. But at the moment, I'm not going to go through on this video. I think there's more achievable marks that we're spending longer time on. And then, because that's still there, I'm not going to use it. This one here, circle theorems, again, I'm not going to do it. It's very tricky. By all means, come and see us. We're not saying you can't do it. Of course you can if you want to. You've got to learn your circle theorems. Inversely proportional, I'm skipping it. Frequency, density, and all this stuff. I did one of these the other day with someone in the class, but again, it's not one that I'm saying is urgent. You need to remember a formula called FD is equal to F over CW, and you can just about see the bold lines here what you'd do is you'd rearrange that formula to find the frequency. We would times both sides by class width. So we get frequency density times by class width is equal to frequency. And then if I read off here, the frequency density, think about it, frequency density, if you've had a bar graph, the answer is not going to be 40. People just write 14 and 18 and stuff there. It's not plotted against frequency. You're not going to get as easy questions of bar graph on question 18. It will be this, I swear. Okay? So it would be 40 and then times by 0.4. 40 times by 0.4, which again, you definitely can do. I'm not going through all of that at the moment though, but if you wanted to, it's there for you to have a go. I'll give you the answer there is 16. They've told you there that answer is 8, okay? I'm not going to go through the rest of those. I'm not going to go through plotting this, okay? But by all means, have a go at it. This one here is probably the last question I'm going to do, but not all of it. I'm only going to go through this bit here. It says, use the graph x cubed minus 6x squared plus 3x plus 10 equals 0, okay? If it says equals 0, it just means where does this graph cross the x-axis? That's what it means. So it crosses the x-axis there, there, and there. So we're just going to read off those numbers. What are the x values? X equals minus 1, x equals 2, and x equals 5. Okay? That's all we're doing on that. We're not doing that question or that question, and then that is the paper. Okay? So we got to a total there pretty comfortably of 64%. If you get 64% in your paper on Thursday, we will be absolutely chuffed to bits, okay? Good idea to work through that again. You know, nothing wrong with doing that paper again, printing it off and just having another go and just seeing how much you can do by yourself at some point this weekend or Monday, Tuesday or Wednesday. Okay, really not a bad idea. Good luck. Carry on with your revision. Really good start to the weekend if you watch this video.